Hi students, welcome back to my YouTube channel. In this video, I'm going to explain the remaining questions of part A of 2019 A-Level Combined Mathematics 1 paper. I have already explained the first 5 questions of the same paper in another video. If you haven't watched that video, I will provide the link for that video in the description. Please go watch that video first and come back to this video again so that you can get a better understanding of this video as well. So I have my past paper with me, so I hope you also might have your past papers. So I'm not going to display the questions. I will just read the question and explain the answers on the board. So please keep your past paper with you while you are watching the video, right? And before watching the explanation, first try the questions by yourself, and then you better watch the video. If you struggle or if you have any issues or doubts while trying the question, this video might support you. Okay, right? With that disclaimer, I will start the sixth question. Okay, right. Now the sixth question says the region enclosed by the curves y is equal to square root of. So there is a curve. Okay, there is a curve. Y is equal to x plus 1 divided by x squared plus 1. This is curve, comma x is equal to naught, comma x is equal to 1 and y is equal to naught. Is rotated about the x-axis through 2 pi radians. Show that the volume of the solid thus generated is. Now we have to find out the volume is equal to pi by 4 into pi plus ln 4. Right. So if you read the question again, so I have just denoted the data given in the question. If you read the question again, you will understand what you have to do. So the region, so we have to find out the region enclosed by these equations. So if I take a coordinate system, okay, so this is x-axis typically and this is y-axis. So there is a curve, this is a curve. Let me take this, this is the curve. So this is equal to y is equal to x plus 1 over x squared plus 1 square root, and x is equal to naught is here and x is equal to 1 is here. X is equal to 1 and y is equal to naught. So we have, this is the region enclosed by these equations. Right. Now if you read continuously, y is rotated. Now this region is rotated above the x-axis. Above the x-axis, this is rotated through 2 pi radians. So it will generate a solid object. So like this, right? So now, for example, if I rotate, so this is the book. Now if I rotate this book through 2 pi radians, so I will get a 3D figure. Okay, so I have to find out the volume of that 3D figure. Right. Now since this is generated through 2 pi radians about x-axis, volume we have studied. So this is actually the application of derivation. So v is equal to pi into naught to 1, because we have to integrate from naught to 1, pi into y square into dx. Right? If it is rotated about y-axis, here we will use x square into dy. That is a different scenario. But here pi into y square into dx. So this is the equation. Right. Now what we have to do is we have to just substitute pi into naught to 1. Okay. Y square. So y square is equal to, now if I put y is equal to here, this one, that is the curve, I will get x plus 1 over x squared plus 1. So I have just skipped one step. I have to write square root and then square, then it will give this one. But I am directly writing this. But in your examination, without skipping any important step, you had better write that, because what you have to do is you have to write square root and then square. Then you have to write this. I'm just, because of the lack of space in the whiteboard, I'm just skipping this line. Okay, right. Now, okay, now you have to simplify this dx. Now I can write this as pi into okay, naught to 1. So I'm going to split this fraction. So I can split this fraction like x over x square plus 1 plus into dx plus again not to 1 over x square plus 1 into dx. Okay, now pi is there, right? Now if I integrate this, okay, so what I can do is not to 1, I'm going to make some changes here. So I'm going to multiply this by 2 and divide entire by half. So the differentiation of the denominator is in the numerator. So the derivation of this function would be half into, I put half, this half comes here, and the different integration of this function would be ln mod of x square plus 1. However, mod is not necessary for this case because this is always positive, and I have to put the limits also, not to 1 plus again this is actually tan inverse x. Okay, this is a direct derivation. Okay, so not to 1. Right. Now, what I have to do is I have to just substitute the values, lower limit and upper limit. So pi into half. Okay. So ln 1. ln 1. Okay. If I substitute 1, ln 1 plus 1. So ln 2. Okay. Then ln 1. So that would become 0. So I don't need to write that one. Plus again tan inverse x, that is equal to tan inverse 1 is equal to pi by 4. Pi by 4. Then it will give you 0. So I don't need to write that one also. Now just simplification. I have to convert this expression into this 4. So I can take 4 out since I have 4 below pi. So I can take 4 out. So this will become, so after writing this one, you can directly write this also, but I will explain how to obtain that one. So pi by 4, I have taken 4 out. So if I take 4 out, it will become 2 ln 2 plus pi. So this can be written as again pi by 4 according to law of indices. So I can bring this 2 to the exponent of this 2. So ln 2 square, that will be ln 4 plus pi. So again pi plus ln 4, that is the thing. Right. Now we will move to the, now I have explained the 6th one. Now we will move to the 7th question. Right. 7th question says, let C be the parabola parametrically given by x is equal to at square and y is equal to 2at for t belongs to R. So there is a parabola. So this is, let me take, this is the parabola, and the equation of the parabola is parametrically given as, and they have named this parabola as C, and C, the equation C is equal to x is equal to at square and y is equal to 2at. Y is equal to 2at. Right. For t belongs to R, and they tell the condition as t belongs to real number. Right. Where a is not equal to 0, and another condition, a is not equal to 0, because if a is not a is 0, then the equation will become 0 0, so that is not possible because the parabola cannot exist. Okay. Show that the equation of the normal line to the parabola C at the point at square comma 2at is given by. Now let's assume there is a point here on C, that is at square comma 2at, at square comma 2at. Okay, here t is a variable because a is a constant, so t is a variable. Yeah. show that the equation of the normal line to the parabola C at the point is given by y plus, so we have to find out, so this is okay. Now at this point we can draw a tangent to the line, tangent to this parabola. So the equation or the, so and this is tangent, and we have to find out the equation of the normal line to at this point. Normal line to the parabola at this point is equal to, so if this is the normal line, we have to find out this is equal to y plus tx, y plus tx, y, where is that, y plus tx is equal to 2at plus at square, 2at plus at cube. So we have to derive this equation from the given information in the question. Right. First, what I have to do is, from the parametrically given equation for the parabola C, I have to find out dy over dx, which will be equal to, the dy over dx will give the slope of the tangent line at this point. Okay, so that's the lid of this. Right. Now what I'm going to do is, I have to find out dy over dx. But here I have the equations are given in terms of t. So I can find out dx over dt and dy over dt. So according to chain rule, I can write dy over dt into dt over dx. Now from this I have to find out dx over dt is equal to 2at and dy over dt is equal to 2a. Now I am going to substitute these values here, that is equal to 2a into 1 over, because I have found out dx over dt, but here I have dx over dt, so I have to use the reciprocal of this one, so 1 over 2at. Right, now if I simplify this, I would get 1 over t. Right. Again, now I have this concept. Okay, so here let's say there is a line with a gradient of m, and there is another line perpendicular to this line having the slope of m. Then the gradient of the perpendicular line would be minus 1 over m. So if I apply this concept here, now the gradient of this tangent line is 1 over t, and the normal line of this parabola at this point is this. So these two are perpendicular. So the gradient of this line is 1 over t. So the gradient of this line would be, so the gradient or the slope of normal line would be is equal to minus t. Now I have to find out the equation for this one. I know the gradient of this line, and I know one x coordinate, so I can apply this equation. Y minus y naught is equal to m into x minus x naught. So y minus 2at is equal to minus t into x minus at square. Now if I simplify this, I would get I have it here. So y plus tx, so this is very simple. Y plus tx is equal to 2at plus at cube. Yeah, so this is what I have to show, that is given in the question itself. So after writing this, you better check whether you get this answer. Otherwise, if you have made a mistake, you have to check the steps, right? So I have shown the very first part of the question 7. So I am discussing the 7th question. Right. Now they are continuously telling the normal line at the point P is equal to 4a comma 4a on the parabola C meets this parabola again at a point. Okay. Now again the normal line at the point P on the parabola C meets this parabola again at the point Q is equal to okay, now let's say this is 4a comma 4a, that is on the parabola 4a comma 4a, and if we draw a normal line at this point, so this will be like this. Okay, right. Again it means a q is equal to a t square comma 2at, right, and we have to show that t is equal to minus 3. Right. Now okay, you have to understand this concept. So what they are telling is there is a point on parabola C, which is the coordinates of that point is given 4a, 4a. And again, if I draw a normal line at that point, and the normal line again meets the parabola at another point, the Q at Q, and the coordinates of that point is also given. That is 80 square comma 280. Now using these hints, we have to find out t is equal to minus 3. So if I think of this question, now 4a comma 4a lies, this point lies on this parabola C. So these points will definitely satisfy these two equations. So I want to use that idea. So x is equal to x is equal to a t square and y is equal to 2at. So x is equal to 4a is equal to a t square. So t is equal to plus or minus 2. Okay. So this will go, t square is equal to 4, t is equal to plus or minus 2. And if I use the y value here, 4a is equal to 2at. So t is equal to 2. Okay, t is equal to 2. So from this we have two values for t, and from this we have one value for t. So plus 2 is both common for both the plus 2 and minus 2 come here and plus 2. So from these two solutions we can tell t is equal to 2. So by putting t is equal to 2, okay, so t is equal to 2. Now I have already found out the equation for the normal line, that is this one. So here a is constant and t is variable. So I have found out t is equal to 2 for this point. So if I substitute t is equal to 2 in this equation, I will directly find out the normal line at this point. So put t is equal to 2 in the normal lines equation. Okay, so y plus 2x plus 4a plus a into 2 to the power 3, so 8a is equal to 12a. Okay, so y plus 2x is equal to 12a. This is the equation of this normal line, and this normal line intersects the parabola at this point Q. So this point, the coordinates of this point will definitely satisfy this equation. So if I put the x and y values of point Q in this equation, I can easily obtain the value for t is equal to minus 3. So let me do that. So here, okay, now I have to just substitute these values. So y is equal to 2at plus 2 into at square, 2 into at square, this is capital T, okay? 2at is equal to 12a. So here a will go. So t plus t square is equal to 6. So t square plus t minus 6 would be equal to 0. So I have obtained the quadratic equation. So if I substitute this is t plus 3 into plus 3 means t minus 2. Yeah. T minus 2 is equal to 0. So from this I can tell t is equal to minus 3 or t is equal to 2. So they have given t is equal to minus t. So I can write only this value. Right. Hope you have understood this question also. Let me move to the next question, which is 8th question, coming from straight lines. Okay. Right. Now we will move to the 8th question. Right. Question number 8, coming from straight lines. They have given the equation for let L1 and L2 be the straight lines given by x plus y is equal to 4 and 4x plus 3y is equal to 10 respectively. So from that I can tell they have given the equation for L1, two straight lines, L1 and L2. So the equation of this one is x plus y minus 4 is equal to 0, and for this 4x plus 3y minus 10 is equal to 0. Right. Two distinct points P and Q are on the line L. So let me take this as L1. So this is L1 and there are two different points P and Q, P and Q, two distinct points P and Q are on the line L1 such that perpendicular distance from the each of these points to the line 2 is 1 unit. So, okay, from this point, okay, let me take this is L2, and from these points, perpendicular distance of L2 is 1 unit. 1 unit. Okay, so these are perpendicular distance. Okay, so okay, you should know that theoretically you should know that. Okay, so there is a line L1 which is given as ax plus by plus c is equal to 0, and there is a point x1 comma y1. So the perpendicular distance b would be given as mod of ax1 plus by1 plus c over a square plus b square square. So this is the equation. So this equation is going to be applied here for this question. So theoretically you should know these things. Right. Now what I have to do is I can easily get. So from this I can tell. Okay, so if I arbitrarily take any point from L1 and I'm going to take x is equal to t. X is equal to t, then y would be equal to 4 minus t. So any point on L1 can be written as t comma 4 minus t. If I take any point arbitrarily from L1, it would satisfy. So t is a variable, right? And now I have to find out x. So this is so t 4 minus t. So this might be t1 comma 4 minus t1, and this would be t2 comma 4 minus t2. Now I have to find out t1 and t2. That is my objective. So this is very simple, no? So what I'm going to do is I'm going to directly apply this equation. So this is L2. L2 is given here. So I'm going to write 1 because the perpendicular distance is given 4 mod of 4 t1 x is t1 plus 3 into 4 minus t1 plus minus 10 mod of divided by 4 square plus 3 square, that is equal to 5, no? That is okay. Now 5 is equal to 4t1 plus 12 minus 3t1 minus 10 mod of. Okay, right, again 4t1 minus 3t1. So t1 again plus 2 would be equal to 5. Now mod means we have two values. Mod means we have two values. So if I take plus, so t1 t1 is equal to t1 plus 2 would be equal to 5. So t1 is equal to 3, and if I take minus t1 minus 2 would be equal to 5. So t minus t1 is equal to minus 7. 7. So t1 is equal to minus 7. Right. Now for t1 we have two values, which means the first value is responsible, or the first value belongs to this t1, and the second value can be applied for the t2, because with the distance of 1 unit we can have only two values. So we have obtained two values for t1. So if the first value represents the t1, the second value will always, or will apparently represents the second value, which is t2. So I have found out both the values. So p is equal, p can be, so we have to find out these two coordinates. So t1, so if I apply 3 here, 3 comma, if I put 3 comma 1, and the next value is if I put minus 7 comma 4 plus 7, 11. So these are the, if this is p, minus 7 comma 11 would be q. Okay, right. Okay, right. Now I hope you have understood this question also. We will move to the ninth question. Okay, so ninth question. So after straight line, we will have a question from circles. Right. Now we will discuss the questions. I mean the question coming from circles. Okay. Right. Now first let me read the question. Show that the point A is equal to minus 7 comma 9 lies outside the circle S is equal to S square. So the equation for the circle is given. I have to write that one. S is equal to X square plus Y square minus 4x plus 6y minus 12 is equal to 0. So after writing the equation of the circle, I have to extract some information from the equation itself. So I can find out the center, so the coordinate of the center. So that is equal to, from this I can write the x component of the center, that is, now this is minus, so plus 2, comma, this is half of this value, the coefficient of x, so then minus 3. So this is center, C is equivalent. Then I can find out the radius also. So the radius would be equal to, okay, so the radius would be equal to minus 2 holding square plus, here minus 3 means 3 square, then plus 12. Okay, so the radius of this, so because see, plus 12, minus 12 plus 12 would be equal to 5. Because, yeah, 5 means I will just simplify directly, okay, without extending the time of the video. I'm just skipping some simplifications. So 4 plus 9, 4, 13 plus 12, so 25, square root of 25 would be equal to 5. Okay, now what I have to find out is, okay, I have to read the question first. Find the coordinates of the point on the circle S is equal to 0 nearest to the point A. Right. Now this point, and they have given a coordinate. So let me take this as the circle, which is S is equal to 0, and the center is here, C, and I have found out the coordinate of that point also. And they have given a point outside the circle, that is A, and the coordinate of that point is minus 7 comma 9, and we have to find out the coordinate on the circle nearest to the point A. So if I join this point and this center of the circle S is equal to 0, definitely this point will be nearest. Okay, so let me take it as P. P. Right. Now what I have to do is I have to find out the CA, the length of CA. So CA, so I have found out this one, 2 comma minus 3. So CA squared would be equal to minus 7 minus 2. Minus 7 minus 2 holding square, because we have found out how to find out the length of a line when two coordinates are given, right? So minus 7 minus 2 holding square plus 9 plus 3. 9 plus 3 holding square. Okay, which is equal to minus 7 minus 9 holding square plus 11 12 holding square. So 9 12 means that would be so we know, right? So triples of Pythagoras, so 3 4 5, so 9 12 and 15, right? So this is equal to 15 square. So from this I can tell CA is equal to 15. So the length of this line is 15 and the length of this line is 5. So this is 10. So the ratio between CP is to PA would be equal to 1 is to 2. So this is 1. So this is 1 and this is 2. And the coordinates also given, and the ratio between the lines is given, so I can find out x1 comma xy1. Okay, so P is equal to 2 into, so I have to find out the x coordinate, 2 into 2, 2 into 2 plus 2 into 2 plus then this one into minus 7, 1 into minus 7, and the total of the ratio is 3, so I have to divide it by 3, comma by component 2 into minus 3, 2 into minus 3 plus 9 into 1, 1 into 9 over 3. So if I simplify this, I will get 4 minus 7 minus 3, so minus 1, comma minus 6 9 minus 6 3 1 minus comma 1. So this is the coordinate of P. Okay, now we will look at the 10th questions. We will look at the 10th questions answer and conclude the video. So this is coming from trigonometry. So they are telling let T is equal to tan theta by 2 for theta is equal to 2n plus 1 2n plus 1 pi, where n belongs to z. Show that cos theta is equal to 1 minus t square over 1 plus t square, and deduce that we have to deduce that tan pi by 12 is equal to 2 minus square root of 3. So this is the question. This is also very simple one. Right. Now if you look at this one, cos theta. So cos theta, I have 1 minus t square, 1 plus t square. So you might have done a lot of trigonometric questions. So the idea should come from practice, right? So cos theta can be written as cos square theta by 2 minus sin square theta by 2. And I have to form tan theta here. And if you just think this, here we have 1 because in the denominator we have 1. Now we have to form tan theta, but we have cos theta and sin theta only. So we have to divide cos theta by cos theta, sin theta by cos theta. Then only we can obtain tan theta. So instead of this 1, I can write cos square theta by 2 plus sin square theta by 2. So this is actually 1. We have already studied in the very first classes of trigonometry. We study these simple equations, right? The basics of trigonometry. Now cos square theta by 2 minus sin square theta by 2. Now what I am going to do is both denominator and numerator. I am going to divide both denominator and numerator by cos theta by 2. Okay, so that I will get tan theta by 2 here. So what I have to do is divide both numerator and denominator by cos theta by 2. So if I divide this by cos theta by 2, I will get 1 minus sin square theta by 2 divided by cos square theta by 2, that is tan square theta by 2. So tan square theta by 2 means tan theta by 2 is t, so I can write t square divided by, here also we will have 1 plus again sin square theta by 2 divided by cos square theta by 2 t square. So I have just proved this. That's all. Fine. Okay, that's all. Now I have to deduce this. So tan theta by 12. So I don't know the value of this one, but I know I have theta should be converted to theta by 2. So if I take theta is equal to pi by 6, then theta by 2 would be pi by 12. Okay, so I'm going to take theta is equal to pi by 6. Okay, so cos, and I have to divide, I have to find out t. So if I take theta is equal to pi by 6, I will get t, that is tan theta by 2 is equal to pi by 12. That would be actually my t. Okay, so cos theta by, cos, here I have to take theta is equal to pi by 6. Cos pi by 6 would be equal to 1 minus, so here I can write t square minus 1 plus t square, where t is equal to tan pi by 12. Okay, right. Now I know cos pi by 6 is equal to square root of 3 by 2 is equal to 1 minus t square over 1 plus t square. Okay, now if I simplify this, square root of 3 into 1 plus t square is equal to 2 into 1 minus t square. I have to find out t separately. So what I can do is I can bring the coefficient of t square this side. So square root of 3 minus 2 t square is equal to 2 minus square root of 3. Okay, so here plus, okay, because minus 2, okay, so it will become here, so it will become plus. So t square would be equal to 2 minus square root of 3 over square root of 3 plus 2. Okay, right. Now I have to get 2 minus square root of 3 if I remove this square. So what I can do is I can multiply, I should have 2 minus square root of 3 holding square. So I just multiply this by the conjugate of the numerator. Not conjugate, actually by the numerator itself. So 2 minus square root of 3, 2 minus square root of 3. So it will become again, so I'm writing over here, t squared is equal to 2 minus square root of 3 holding square divided by, now this is a plus b into a minus b. So 3 minus 2, that is equal to t squared is equal to 2 minus square root of 3 holding square. So t is equal to 2 minus square root of 3. So I have reduced this one also. So actually t is equal to tan pi by 12 is equal to 2 minus square root of 3. So I have obtained the deduction part also. I hope you have understood the 5 questions I explained in this video, and previously I have uploaded the explanation of the very first 5 questions. So if you haven't watched that, you better watch that video as well. So we will meet in another video, and if you haven't subscribed to my channel yet, please subscribe immediately, so that whenever actually during my free time I'm uploading these videos, and whenever I upload my videos, you will be notified if you subscribe to my channel only. Okay, so with that information I conclude the video. We'll meet in another video. Thank you.